Exercise 3C and D. So today we're looking at reflections and then combining transformations. What you need to be able to do is understand the notation of mapping, map a translated point, map a translation onto an existing function, find the transformations given a transform function, and this is all going to be pertaining to reflections and then a combination of different ones. You're going to notice that this is very similar to last lesson, except now we're looking at the transformation of reflections. So when we're talking about our new x and new y, that is defined as our old x with a negative in front or our new y with a negative in front. And it depends on the reflection itself. So a negative x, which means all of our x values now are negative, that would be a reflection in the y-axis. So there's the y-axis, that's like our mirror image there. If I do a negative y though, means all of our values that were positive now become negative. And so that's what we would call a reflection in the x-axis. We've been doing reflections for a very long time. So now it's just kind of defining it more mathematically. So say we take a square root graph, this is the standard graph here, we would say that that's y equals to root x. If we were to reflect it in the x-axis, as in that would be our mirror, it would look like this. Now, how do we get that? Here are all of our positive y values. The x values, as you can see, don't change, but our y values are now the negative version of it. So y is equal to the negative of what it was. So before it was root x, now it's going to be negative root x. So that will take all of our y values and just chuck a negative in the front. When we have a reflection in the y-axis, however, what you'll notice is that all of the y values stay the same. So if this were our original, all the y values are the same, but now all of our x values are flipped. How do we achieve that? We achieve that by putting a negative in front of the x, because particularly with a square root, you can't take the square root of a negative number. So now this will only work for if I have a negative, if I put in a negative x. So that'll be negative times -1 will give me root 1, and then that will just give me the normal y value of what I would have received as if I had put the +1 in there. So the negative and negative cancel out. Of course, you can have a reflection in the x and the y-axis, and that would be negatives on both the outside and the inside. Okay, so with a reflection, we essentially talk about it like it's a mirrored point. So if we have the point 1 and 2 and it's reflected in the x-axis, it becomes the point 1, -2. So what's happened is my y value has become the negative version of what it was. So if we were to practice this, determine the rule of the image with the equation when it's reflected in the x-axis. Of course, you can do this through the dash method, or you can kind of just have a look at it and write out whatever the answer is, just so that we can really hammer in the practice. I'm just going to go ahead and do the dash method, but hopefully you can all just look at it straight away and know exactly where that negative should be. Now, with the dash method, first thing we do is we apply the transformation. So reflection in the x-axis means it's going to affect my y values. So we're not doing an equal, we're defining it. So x stays as it is, but y has become the negative version. We will equate, we will rearrange. So divide by -1, and then we will substitute into the original equation. So that will be negative y dash is equal to root x dash. And of course, convention wise, the negative is, or the y has to be by its own. So I would divide by negative, so we would get that. Hopefully you can recognize though that a reflection in the x-axis anyway is putting a negative out the front. Okay, if instead we want to look at reflections in the y-axis. So the y-axis is where we have this as our mirror image, and you can see the x value is now the one that's changing. So if we have the point 1, 2, it's reflected in the y-axis, it becomes -1 and 2. So that is the negative version of x. So we'll try with this one, determine the rule of the image when the equation y equals root x is reflected in the y-axis. Again, if we were to apply the method with our 5 steps. So our new x and y, so as we said, a reflection in the y-axis means that our x values are going to be affected. We will then equate. Sorry, this should be an arrow, not an equal sign. We will then rearrange to get the old by itself, so I can substitute that in. And then we will substitute. And there's not really much that we can do anything for step 5. So we can't rearrange it anymore to get y. Hopefully you can see that a reflection in the y-axis means that the negative is attached directly to the x. Okay, so in summary, we are looking at these two transformations here, and then if you follow those 5 steps, it should quite easily result in those in that transformation. Okay, so now we're getting to the exciting part because this is where we're going to combine several of the transformations together. So we're going to start off very simple just by thinking about a point, and then eventually we'll get to a point where we're thinking about a whole function. So find the image of the point, and remember the word image means the new of the point -2, 3 under the following sets of transformations. So when I'm looking at this, I'm going to try to apply the transformations to my particular point. To do that, I'm going to consider all of the different transformations that have happened, and the order is really important. So make sure you keep that in mind. So first we have a reflection in the y-axis, and then there's a dilation factor of 2 from the x-axis. So that's the first thing that has happened, reflection in the y. And then we have a dilation of factor 2. Now, if I start off with my old points, x and y, and I write it like this with lots of space so that I can write down all the different transformations. First, I'm going to apply this one, the first transformation. Reflection in the y-axis means that there's a negative in front of the x. Then we have a dilation of factor 2 from the x-axis. So from the x means it's going to affect the y. That means all of my y values multiplied by 2. I've obviously left way too much space here. We don't need that much space, but just in case there's lots of transformations. Okay, so my coordinates, or the x dash, y dash, is going to be defined as old x, so times negative, and new y times 2, the old y times 2. And now all I need to do is substitute this point in. So -2 and 2 times 3. And so you can see this 2 and 3, they were our old points. That was the old x and old y. And that is going to give me my new transformed point, -2 and 6. So now we're going to start the exciting task of combining all of the different transformations. We're going to start off very simple just by looking at a single point, and then eventually we'll get to functions. So with example 8, it says find the image of the point -2, 3 under the following sets of transformation. And again, just a reminder, image means the new point. So we're looking at the point -2, 3. What I would do is start off by highlighting all the different transformations, and remember the order really matters. So you have to make sure that you keep it in the correct order. So reflection in the y-axis, followed by a dilation of factor 2 from the x-axis. So first, and then second. So what we can say is that the new x and the new y can be defined as, now I'll usually write a large coordinate so that there's plenty of space to write down all of the different transformations that needs to happen. So the first thing says it's a reflection in the y-axis, which means all of the x values, it's the negative version of it. And then a dilation of factor 2 from the x-axis. From the x-axis means it affects the y value. So we'll have 2 times all of my y values. Okay, so now if we were to apply this point, so this is x and this is y, old x and old y, I can now substitute that directly into this coordinate. So our new x and our new y are going to be negative. So old x was -2, new y is 3. So that can simplify it down to be 2 and 6. So that would be our new x and that would be our new y. Okay, if we were to do it for part B, which is a little bit more involved, let's have a look, highlighting all the different transformations and labeling them in order. So we've got a reflection in the x-axis, then we have a dilation of factor 2 from the x-axis, translation of factor 2 in the translation, sorry, of 2 units in the positive direction of the x-axis, 3 units in the positive direction of the y-axis. So we've got 4 transformations there that we need to include. Same idea, new x and y can be defined as, now I'm just going to write my coordinates out a little bit bigger this time because there's going to be more involved. So starting off, so there's an x and y. We've got a reflection in the x-axis. That means all of our y values are going to be negative. So that's done. Then a dilation of 2 from the x-axis. So from the x-axis means that all of our y values get multiplied. So I really should have left some space there because there should be a 2 in there. Then we'll have a translation of 2 units in the positive direction of the x-axis. That means I'm going to add 2 to every x value and 3 units in the positive direction of the y. So we'll add 3 to everything that's happened to the y. All right, now I can go ahead and substitute in my old x and old y. So that was -2 and y is 3. All right, so that means new x and new y can be defined as -2 plus 2 is 0. -2 times 3 is 6 plus 3. Sorry, -6 plus 3 is going to be -3. So that there would be my new coordinate. Okay, hopefully that makes quite a bit of sense. You just need to figure out what all the different transformations are, write out the new coordinate, very much like what we did before, but this time I can just substitute directly in x and y. Okay, so we're going to now do this not just for a singular point, but for a whole function. So it's actually going to follow very similar to what we just did before, which is to apply all the different transformations. But then instead of substituting in actual values for x and y, we're going to substitute that into the old function to be able to get the new, just like we did previously. All right, so the dash method, remember the first step of the dash method is to apply. So I'm going to go through all of these different transformations in order. Again, remember, it's very important for the order. And I'm going to create my coordinate. So again, I'm going to make it quite large because there's probably a lot that's going on. Okay. So let's see what's happening. So first of all, we've got a translation of 3 units to the right in the direction of the positive horizontal. So I'm going to add 3. Dilation by a factor of a half from the x-axis. That means that affects the y. Translation of 1 unit down that means the negative, so we're going to subtract 1. And then we've got a reflection in the x-axis. So in the x-axis means it affects the y values. Now this is what I mean by order is really important, because after I've done all these transformations, then there's a reflection. So it's really important to have that bracket, otherwise you're not going to get the correct function in the end. Okay, so that was our first step to apply. Now the second step is we're going to rearrange. So, or rather, sorry, equate first, then we rearrange. So our new x is equal to x plus 3, and our new y is equal to -1/2 y minus 1. Now we're going to rearrange so that I can substitute it into my equation, because remember my equation is old y and old x. So I need to get old y and old x together. So this one's going to be a little bit trickier. So first we multiply by the negative, then I'm going to add 1, and then I'm going to multiply everything by 2. So if you can't do it in one step, that's okay. It's just to kind of speed up the process a little bit. Okay, and then finally, well, not finally, but the fourth step is we're going to go ahead and substitute in. So this is old x, we'll go into old x, and don't know why I put a dash there. That should be just old y. We'll go into old y. So that'll be 2 -y dash plus 1 is equal to x dash minus 3. Right, our last little step, so there should be a square root there, of course. So our last step now is to go ahead and rearrange again to get y by itself. Rearrange to get y by itself. All right, so first thing I'm going to do is I'm going to take the 2, so I'm focusing on this side here. I need to get rid of the 2, the negative, and the 1. You just need to make sure that you do it in the correct order. So first I'm going to divide by 2. So we'll have 1/2 root x minus 3. Then I'm going to take the 1 over by subtracting 1. And then I'm going to multiply everything by negative to get rid of that negative in front of the y. So that would be negative and then a plus. So this will be our final equation. Now, I usually receive a comment after this question being like, hold on, the transformation clearly said that I'm going 1 unit down. Why on earth am I adding 1? That doesn't make any sense. But again, it's because the order really matters. Because after I've gone down by 1, I then have reflected in the x-axis. So if this was my point here, it's reflected and it actually ends up looking like it's gone up by 1. So I can't stress enough how much order is really, really important for these whole steps. Okay, now this is where things kind of get tricky because in this example, they want us to just kind of look at it and be able to tell what happens. And to me, I personally don't like doing it when it's this many steps because it's so easy to make a mistake. Like I prefer to just do the method and know that I'm going to be 100% correct rather than trying to substitute in the function. Let's give it a go. We'll see how it goes. It might not work. It might be fine. But again, it's all about playing to whatever you're confident with. So this is the function I'm starting off with. Let's go through one step at a time. Again, order matters. First thing it says is translation 3 units to the right. So we know that if it's to the right, yes, it's plus when we're going to the right, but we do the opposite when it's attached to the x. So that means it should be -3. Next thing it says is dilation by a factor of a half from the x-axis. From the x-axis means it affects the y values, which means we just need to put that out the front as it is. There's no tricks with that one. Then it says there's a translation of 1 unit down. So that would mean that I would subtract 1, because again, it's affecting the y values. And the last one is a reflection in the x-axis. So in the x-axis means I'm multiplying the whole function by a negative. So it's really important to include those brackets. So in this case, I'm going to now expand it. So it looks like that. And you can see that the negative times a negative will result in a positive. That actually wasn't as bad as I thought it would be, given that there's so many transformations. So maybe it is fine to do it this way. But for me, I just prefer certainty. So I know that I'm definitely correct when I do this. Um, with this one, they're actually quite straightforward transformations, but you never know what you might get. So that's the end of this exercise. See you next time.